let's get to identifying the specific services, because this is by many means the most important and useful part of our network activities, right? Connecting to services and getting some use of them. And in the penetration testing especially, that is the closest part to identifying how actually things can be attacked, right? Because back in the day, in the 90s, for example, yeah, remotely exploitable TCP/IP stack level vulnerabilities were pretty common. At least there were some. Now, fortunately for many, these days are gone, right? So now application programming, not system programming, poses the most risk to information systems. So identifying active services is the closest step we take in order to approach our targets in terms of exploitability. Okay, so what can we do in order to identify active services? So first of all, we can just use them legitimately. Okay, so we can employ file managers of our operating systems or web browsers in order to attempt connections to the file shares, to possible web servers or web services, and so on. So just trying to establish legitimate or connections looking like legitimate, we can already have some information. Yeah, it's not very practical because there is a lot of work to do, and the manual approach is ineffective. And but still, we can yield really cool results very quickly by doing that, running on the background our favorite network mapping and service scanning tools. Okay, so why not? We just see the web host, we see that we can connect, we see the administration interface protected by login and password, and we are trying to submit some very popular default credentials or something, or already typing in some SQL injection polyglots or something, you know. So we are like performing our normal hacking operations while in the background we have Nmap with all the cool features and switches turned on, you know. So yeah, that's the first thing we can do, but we should not focus on that for a long time. We have to automate a lot, especially when we have large scopes. Second thing, of course, we can use something more specific. For example, we can see a service that is not normally connected by our user-land utilities, right? We can see an SMTP host, for example. Yeah, so running on port 25, we can see a service that is most probably an MTA, and we can connect to it by netcat, for example, the simplest thing that initiates TCP connections. And there are different flavors of it, for example, NC or netcat. These are classic netcat flavors, and ncat is the one that is coming with a map installation, the same way that we had nping previously, right? So these are cooler than telnet because they are not expecting anything on that side to behave similar to telnet, right? So we just establish a connection and see what happens. At least we will see a banner maybe, or at the minimum we will just see that the connection is established by netstat, or just by waiting for a while and seeing that it is not dropped right away. Also, we can continue using telnet for that. However, ncat is much more capable. Okay, so but there are cases when we still need to behave as telnet, and for that, these are not telnet only situations. Some versions of SMTP mail agents, for example, Microsoft eSMTP coming with Exchange, yeah, they expect you to end the lines as Windows Telnet does, for example, right? So you will have to behave as Telnet using this -t. switch, and you will have to end lines with Windows-like enters. Yeah, so Windows-like, in a Windows-like manner. So this is what is accomplished by using the -C. Okay, so sometimes there are SSLs on the network. Yeah, so day by day the use of SSL is becoming more and more prevalent, and overall it's a good thing. But for penetration testers, it comes with some issues. For example, yeah, you see the TCP connection, but you can't do anything about it because someone on that site is expecting you to start transport layer level SSL handshake. So you are not expected to just go through TCP handshake and then hang for undefined period of time, right? So you will have to ask for the certificate, and then validate that locally, and then proceed with some SSL related commands. What to do then? We can use S-client component of OpenSSL. What it does is basically goes through this traditional SSL handshake. And it's really capable. It can even authenticate using your local user certificate, but in this case, let's just limit that to establishing TCP connections with the SSL protected services. Okay, the same thing is done by Netcat with these options, right? --SSL. And you will encounter, most probably you will encounter situations when connections to TCP services like SMTP, for example, are allowed only using TLS, yeah, so only using SSL. There are ways in both these tools to maintain that state, to start TLS, right, literally by this keyword of SMTP protocol, and continue communicating through SSL protected connection, right? Yeah, so read more about it and play around with these tools, and most probably we will have a demonstration of that later. Then, what comes next? When these things are performed at large scale, of course, we will need to automate. What are the means to do that? So, there are different scanners, okay? So, just to name some that are not Nmap directly, so there were different approaches to build something similar to Nmap for a long time, but I don't know, maybe this is some manifestation of Darwinism or something. In the end, only one version of this network mapping tool has survived and is maintained very actively and is developing always in a good pace, and it's basically established the standards for this mode of operation, right? So there are alternatives, but they are left behind by Nmap and do not make any competition. So for example, Unicorn Scan was a really good start, but now it's not maintained for a long time. SuperScan is just a scanner for Windows, which is still used by someone. If Windows is your working platform, maybe that's okay, but Nmap still is well available on Windows too. Mmap is also interesting, and it doesn't outplay Nmap, but it's really effective on the operating system and service enumeration. So when you are trying to fingerprint something, maybe a map can give you some advantage. These two, MassScan and ZMap, as I said, they scan really fast a limited number of TCP ports on a large numbers of IP addresses. So if you want to map a really large scope, you have to use one of them. So they are pretty much equivalent in their abilities, but I think ZMap is just scanning one port, and MassScan can get the list of ports for subsequent scanning. Okay, and now the most interesting and important part of this. So let me introduce to you the Nmap tool in its original design. So what's the reason for it to appear? in the software market. So it's open source, first of all. It's designed by network and security professionals, and it's developed uh, by the vision of providing the so-called Swiss Army knife to everyone who wants to really get down to the network level. So every time you need to operate on this large scale but very low level of network interaction, you have to use it. At some point you will just, there will be no other options. So originally it has been created for network mapping, as you can guess from the name of the tool, but now it's not even a tool of choice for identifying active services and hosts and mapping networks and so on. It even has this very flexible and rich scripting capability that is used by many security professionals to produce basically the scripts that are run in line with overall nmap operation, and they can be used as vulnerability detection tools. Okay, so very common and very critical vulnerabilities are now being actively detected by nmap. So yeah, you can do all this stuff. You can do live host detection, service enumeration, service and operating system, fingerprinting by very large and industry level vulnerability testing software. Yeah, but to tell you the truth, there are penetration tests when I personally do not even start an Nessus or an Expose or something like that, because everything I need is actually in nmap and can be used to the same level of quality and the same amount of results. So what is the need for creating all this extra noise that is inevitably generated by more complicated tools? I don't know, but still, there are people who just fire up an expose and get caught by security operations guys. Okay, so to stay under the radar, you will have to use nmap. Okay, and two important things you have to know right from the start is that first of all, nmap is running different functionality depending on what permissions in the system it has. Okay, so you run nmap with root and without root permissions, you have different network activities generated. This is kind of funny and tricky in a way, but if you think about it for a while, you will understand that this is really, really logical. Root accounts have more permissions. They can, for example, generate half-open connections, like sending SYNs and receiving SYNX and not doing anything else. Basically, yeah, speeding up the operation of service enumeration tremendously. So just sending one packet and listening to one packet is much more fast than establishing a full TCP connection, right? So these are the basic things you have to understand. This SYN versus connect is important because SYN, for example, is faster, but connect is more accurate when it comes to avoiding interference by the devices that are between you and your target. For example, you have a firewall and it can be configured by security obscurity fans, yeah, in order to reply SYN-ACK to any SYN attempt. So this can be really tricky. You see the nmap output and it shows you that every single port on the host is open. On the other hand, if you run nmap as a normal user, not root, or as root by specifying this -- unprivileged option, yeah, you will have full connections, and there will be no reason for a firewall between you and your target to prevent that, because it will interfere with the normal mode of operation of this service behind the firewall. Okay. Yeah, so this is the difference between root and non-root execution of a map, and this is the first implication you will normally encounter, right? So root runs even very basic scans employing this SYN technique, this half-open connection technique, and non-root or root with unprivileged flag will execute full connections. Full connections are longer to take, but more accurate. And what about UDP? UDP basically, as you already know, it's a protocol that it's a part of TCP/IP protocol stack that is not relying on something coming back. So first of all, it doesn't guarantee you that your packet will reach its destination, all right? And it is not basically expecting anything coming back. So it does not provide you control over your network communication with your target. So what does it mean in terms of penetration testing? It takes enormous amount of times to scan via UDP. Okay, so there are useful UDP services for penetration testing. SNMP, for example, is very important. It provides you a lot of information about the scope, and it can be exploited in different ways. But if you scan, for example, all 65,538 ports, UDP ports on a specific host, or some portion of UDP port numbers on a lot of hosts, you will wait for quite a long time. So how can you increase the speed here? If you expect the packets to come back really fast, you can just limit the time of Nmap waiting for this response. Say you are connected to a specific network physically, okay? So you know that everything that happens will happen in a fraction of a second, yeah? Or it won't happen at all. So you can use specific switches that will just limit the amount of time you will wait, because scanning via UDP, that's basically what Nmap does. It just sends the packet and waits for some period of time for something to come back. If nothing comes back, it assumes that there is nothing there. The port is absent or closed or filtered, but it is not sure. That's what UDP is, Okay, so yeah, let's give you a basic idea of how important the map is, and what are different modes of operation, and how flexible it can be in shaping this mode of operation by different configuration options. We will have a lot of data about Nmap coming in later. We will have a separate demonstration video for that, so just be patient.